Hello, everyone, and welcome to my YouTube channel. Today, we have something special for you. We are going to take a look at how to approach NLP problem, specifically text classification. And this video is going to be really very beginner friendly. We have just today started a new competition sponsored by Data Driven Science, and we have two people from Data Driven Science here today, Jan and Prashant, who will be walking you through the Hugging Face competition platform a little bit, how to make a submission, how to download the dataset, and things like that. And we will also learn a little bit about what data driven science does. And if you go to the competitions page, huggingface.co/competitions, you will find like we have three ongoing competitions right now. And the one we are going to talk about today is movie genre prediction, in which you are given a data set with movie synopsis and movie title, and you have to predict the genre. But I'm not going to talk about it any more than that. Uh, Jan, do you want to talk a little bit about data driven science?
Yes, yeah. Thank you so much, Abhishek, for the introduction. Welcome everyone. Very excited that you joined this live stream here, where we talk about the movie genre prediction competition that launched today. I'm Jan. I'm the founder of Data Driven Science, and to give you a little bit more context, what Data Driven Science does. We are an education company, and we are focused on teaching practical machine learning skills. What we believe is that only through practice you can actually really build the skills needed for working as a data scientist. And although traditional online courses are great to build fundamental knowledge in the field, at the end, you have to be hands-on and actually do things. This is what we do, and our product and our education tool for that is the so-called Data Science Challenge. And the challenge is very hands-on, and we focus on specific topics, mostly in computer vision and natural language processing. And since we are so hands-on and focus on the practical aspect of machine learning, we also really like the competition, which is fairly similar to the challenge we develop on data-driven science. But it is also the competition is you're even more on your own, less guidance, and you have to come up with the highest performance model to win this competition. Therefore, we are very happy to partner with Hugging Face and specifically Abhishek to create competitions that people can join and participate to learn and compete with others. That's a little bit about the company and why we're also excited about competitions because of that practical aspect. And if you want to learn more about data-driven science and our challenges we run, just go to datadrivenscience.com. We also have a free 3-day object detection challenge that you can join anytime. Okay, I want to now hand it over to Prashant, who is working also for data-driven science, and he will give a quick introduction and then go deeper into the specific movie genre prediction competition.
Yeah, so thank you, Jan. So I'm Prashant, and I'm a computer vision researcher and engineer. So today here I am going to.
Sorry to interrupt you, Prashant.
Yeah,
Just wanted to let everyone know, like, if you have any questions,
yeah,
please ask in the YouTube chat or LinkedIn chat or wherever you're joining from, and we will be watching the questions and we will be taking all of them.
yeah,
Sorry.
yeah. So now proceeding with the movie genre prediction. So here I'm going to give you a small insight how actually you can approach for this movie genre prediction, how actually you can write a basic code for approaching for this problem, And so very firstly, let's go through with the movie gender prediction. So if we just quickly see a data set, so here is the data set of the uh, this particular competition. So in this data set, we'll be having the three main attributes: movie name, synopsis, and genre. So movie name and synopsis are going to be the independent parameters that are going to be used for predicting the genre. So this is the dataset which you can download. And for downloading it, very firstly, what you have to do is you have to get your Hugging Face token. So that you can get by going into settings, and after that by clicking on access token. And so from here you can copy it. And if I go to my client CLI, so I'm presenting my screen. So here in the command line interface, you simply have to type Hugging Face CLI login and enter. So here you have to paste your access token, which you have copied from the access token part from the Hugging Face website. I'm pasting it, and when I press enter, so it asks that, do you want to add the same as my Git credential? So I'll be saying no, and pressing enter. So it says the token has been saved and login successfully. So this is how actually you can log into the Hugging Face to download the dataset. So now moving towards code part. So this was the dataset in which, as I said, two independent columns or attributes, that are the movie name and synopsis, and the dependent parameter that is going to be our prediction parameter also, that is genre. So now let's quickly move towards the code. So very firstly, we have to import few libraries that will be including NumPy. After that, we'll be importing pandas. Pandas as PD. After that, we'll be importing torch. Afterwards, for downloading the dataset, we'll be using the datasets, that is the library from the Hugging Faces datasets, and we'll be importing load dataset from it. After that, we'll be importing the sklearn. We'll be particularly importing the metrics from the sklearn for evaluating, and at the end, we'll be importing transformers that we are going to use for tokenizing, for classification model. So for all of it, we are going to use transformer. So sequence classification. After that, we are going to import auto tokenizer. So I'll also be explaining you guys what all these things. So this is just the importing part. So after that, we are going to import training arguments. Yeah, so that's all for the importing part. Now coming on to our preparing our data set. So this is the most important part whenever we are working with any machine learning problem. Either we are working with the image, either we are working with the text, either we are working with the audio. For all of them, we have to do some pre-processing, some data filtering, some data which is null that we have to remove. So for that, very firstly, I'm going to create a class. I'm going to name my class as the classification dataset. And afterwards, here I'm creating a constructor. First parameter should be self. Second parameter I'm going to pass into it is data. Afterwards, tokenizer. Self dot data going to be equals to data self dot tokenizer is also going to be tokenizer. Afterwards, we are going to define a length function. And here we have to return the length of data. Afterwards, we'll be having the get item, and inside that we'll be passing our. So very first thing will be text that we are going to get inside it, and it is giving error. Let's see. So string self dot data, and from inside it we'll be getting every item, and from that, so here I've put them. Okay. So from there we want synopsis, and we want to separate it with our target variable, that is going to be our general. So self dot data, and putting here as the item generate. So inputs is equals to, so now we have the text, that is our synopsis. So now what we have to do is we have to tokenize it, and that tokenizing part is going to be taken care by this tokenizer. So for that we have to create an object also. So here is the tokenizer object which can be utilized, and self dot tokenizer, inside it we have to pass text, and max length we want our tokens to have as, I'm putting the 20 as a value. You can change it also. So afterwards I'm putting a padding into my text, that is going to be max length, and truncation is also going to be one of the parameter which I'm going to have as. Afterwards, let's go to the IDs, because here we are going to make a prediction according to the IDs. So input IDs and mask also. Inputs, attention, mask. And from this function, we are going to return input IDs, and input IDs are going to be in format of tensor. So for that, we have to import it from torch. IDs will be getting as the output, and data type is going to be torch.long. So another thing is going to be attention mask. That too is going to be as the tensor. So here is going to be mask, and again data type will be torch.long. Afterwards, we are also going to return label. Okay, so here I have to put comma. Labels also we are going to return. So torch.tensor, and target is going to be a return value, and here also torch.long. Okay, so this class is for preparing our data. Now let's quickly write the training function which we are going to use. So let's define a train function, and here comes our dataset. So very firstly, we have to load our dataset. So dataset can be loaded from the data-driven science repository, and inside that you have to type in movie genre prediction, and simply by this way you will be able to load the dataset. Afterwards, what we are going to do is we are going to get our dataset encoded. So df.class class encode column. And inside that we want to pass in our target variable, that is going to be genre. Afterwards, we want to split our dataset into training and testing part. So for that, so the dataset has already the attributes train and test. Oh, sorry. So we particularly, very firstly, we have to split it into training and testing. Afterwards, only we will be able to use it. So very firstly, let's define it. Df train is equals to df train df test is equals to df of test. So these are the data frames, and temporary data frame I'm going to create, that is going to be my splitting. So I'm going to split my training data into the training and validation, we can call it as. So for that, let's split our train data. So the function which I'm going to use, that is train test split, and my test size will be 20% of my whole training data. After that, I'm going to give the stratify parameter, stratify type column, and that is going to be my target variable, that is genre. Afterwards, df train, that is going to be my training data, and df validation, that is going to be my test data, which I have just splitted. So here I could get it as test. So I hope so till this point everything is clear. If anyone has any doubt, they can drop in their comments. We'll be taking them. So this was the part in which we were importing the dataset from the Hugging Faces from this repository, which you can see here. And after that, so this is the reason we have logged into the Hugging Faces CLI at the very starting of directly jumping into the code. So this is the training and test data, and here we have split it into the validation. We have split it our train data into the train and validation. So here we can see our train and validation data. I hope so everything is clear till this point. Now we are moving towards
I think
logging
we
and
have
tokenizing.
a comment from a
So
viewer.
for that, tokenizer equals
So
to,
I
so
think
for tokenizer we are going to use the auto tokenizer that is available in the transformer. So for that, let's write auto tokenizer
so Prashant, I think we have a
from
comment
the
from a user.
pre-trained weights. So here we are going to use the BERT. So we can simply write BERT is uncased, and we'll be use fast parameter, and the model now we have to use. So this is just for the tokenizer which we have designed for BERT model. And after that, now coming on to the model, designing to the model. So for that, we are going to use auto model for sequential classification. That too, we are going to import pre-trained, and inside which we have to pass our parameter that is going to be same as BERT base uncased. So afterwards, now moving towards the labels. So number of labels also we have to mention here. So number of labels is equals to is going to be our length. So this function which we have written here, length, this is going to be giving us the number of genres. So let's see how actually we can do so. So length of df train and dot features, and we are going to choose the genre feature. For that, we are going to use into string. Okay. So after doing so, we have chosen our model that is going to be BERT. We have created a object for tokenizing, also for tokenizing the dataset as well. Now we are going to use this class, that is classification dataset. So let's go for it. Now let's very firstly create the train dataset. So for that, we have to call classification dataset, and inside which, let's see what all parameters we have to pass. So we have to pass very firstly our dataset and tokenizer. So here you can see data and tokenizer. So let's pass both these parameters inside it. So our dataset is tf train, because here we are creating a training dataset. Afterwards, we have to pass tokenizer. Afterwards, let's do the same for the validation dataset as well. So validation dataset. Afterwards, same thing. Going for the validation tokenizer. Same thing for the test dataset as well, because for all of them we have to tokenize. Tokenizer, and yeah. So now here we have prepared with our dataset, means that tokens has been created by the tokenizer and the data is set is prepared. So now let's write the arguments which we are going to pass inside the model for training it. So for that, we are going to use training arguments function. So let's do so, training arguments, and inside which we are going to pass few parameters. Let's see. So very firstly, we have to define the argument of the model, that is going to be model. After that, we have to define evaluation strategy. So evaluation strategy. So that is going to be epoch. Afterwards, saving strategy. Epoch. Afterwards, learning rate we have to mention. So these all are the arguments which are going to be fed into the model at the time of the training. So I'm keeping it as the 2 into 10 raised power minus 5. Afterwards, we have to put the argument per device train batch size. So per device train batch size. that I'm going to put 8 for now, and the same we have to do for the evaluation as well. Evaluation. And for the evaluation also, I'm going to put it as the 8. Number of training epochs for which I'm going to do it. So that for now, I'm going to keep it as the 1 because BERT is quite heavy model. So it is going to take quite a lot of time. Afterwards, weights decay. So I'm going to put it as the 0.01. And afterwards, I'm going to put at the end, I want to load my best model at the end. So that I'm going to put as the true. Afterwards, so the metrics on the basis of which the matrix is going to be designed. So for metrics, best models, on what basis actually the best model will be decided. So that I'm going to put it as the accuracy. Afterwards, there are a few more parameters, that is report to, that I'm going to put it as the none. Afterwards, save total limit. This parameter also I'm going to put as the 1. So these are all the arguments which are going to be used for training. So now we are going to design our trainer. So for that, we are going to use the trainer class. So this is the trainer which we are going to use. Inside the trainer, let's see what all parameters we have to pass. So very first thing that we have to pass is model. So this is the model which we have defined. Afterwards, after the model, we have to pass the arguments which we have defined just now. Afterwards, we have to pass train dataset. That is going to be our train dataset, which we have defined it here, as you could see. After that, we have to give our evaluation dataset. So evaluation dataset will be validation dataset. Afterwards, we have to put tokenizer, which we have designed tokenizer, and at the end, we have to put compute metrics, on the basis of which the metrics will be decided. Compute metrics, and that too is going to be compute metrics. So compute metrics is giving error. So this is giving error because we have to define a function that should compute the metrics as well. So for that, let's quickly define it here. Compute metrics. So inside which the evaluation prediction will be the input. So very first thing will be the predictions and labels. They are going to be come out of the evaluation prediction, and what all predictions we have got, we have to convert them into argmax so that we can get the output what actually is the genre which has been predicted by the model. And at the end, using this prediction and labels, we are going to compute the accuracy. So here is the accuracy. So for the accuracy, we are going to use the metrics. So this is the metrics which we have called it from the sklearn. So the accuracy score, we have to pass on both things, labels and predictions. And from this function, we are going to return accuracy. So now we have defined a function. So it should not. Okay. So here I have to put E and here. So now we have defined a trainer as well. So now we simply have to call this trainer which we have defined it here. So for calling it for training, so we simply have to trainer.train. Simple. Now we want to do prediction as well after the training has been completed. So for that, we are going to use the trainer itself, trainer.predict, and inside which we are going to pass on the test dataset on which we are going to make the prediction. So yeah, so now here we'll have all our predictions inside the spreads. Afterwards, the spreads is going to give the probability of all the genres which every particular record can have. So for that we have to apply again argmax, inside which we have to pass on the spreads and access is equals to 1. So now at the end, so once we have generated the predictions, we have to submit it also. For submitting it for the completing the competition, so here I'm going to generate submission file. So for that, submission format is going to be, I'll show you up. So let's see very firstly how actually we have to submit it. So just give me a second. I'll be showing you how actually the sample submission should look like, so that after that we can code it. So let's see. So this should be a sample submission file in which very firstly the IDs of all the genres should be there, and corresponding to that the genres also should be there. So this should be our submission file format. So for that, let's code it. And so very firstly we have to create a data frame inside which the ID should be there, IDs. And so for that IDs, you can simply go for the df test, inside which we can get the IDs, and corresponding to that we also want to have the genres as a column. So genres are going to be reds, which we have made the prediction. So now coming to the converting this data frame into the CSV file. So I'm going to select all of it and genre. Afterwards, I have to apply genre.apply. Small function. Let's see what we are going to do. So here what we have to do is we have to convert all the integers. So all these spreads, whatever values we are having, so they are going to be into the integer format, so that we have to convert into strings, so that we can get the genre, what actually is the genre in a textual format, in a string format. So let's see how actually we can do so. So for that, simply we have to have the features from that I'm going to get from the df train. So features, and inside that I'm going to go inside genre. Afterwards int to string, and my input for this function is going to be x. So I think everything is good. Okay, so here I've done a mistake. Yeah, so now it is good. So now we can export this data frame as a submission file. Submission.csv we are going to name it as, and index should be false. Yeah. So now pretty much we have created a trainer, we have created a metrics, compute metrics, we have created our dataset preparation. For preparing our dataset, we have created a class. So yeah, now we can start our training. So for that, let's quickly define our main function. I'm going to call train function outside inside it, so that it can call all the things. Okay, so now we are good to go to start the training. So here is my terminal. I'm going to type in Python 3 and name of my file is generic classification. Okay, so it has downloaded the dataset. Here you can see. Okay, so weights decay. There's a small error. Let's quickly go to it. Weights decay.
Also, while Prashant is
Okay, so
debugging,
it should be weight decay.
if you have any
not weights
questions,
decay.
please feel free to ask them in the chat. Prashant, do you
Let's
hear me, by the
quickly
way?
rerun it.
Okay, it seems like he's not hearing us. But yeah, if you have any questions, please ask them in the chat.
Okay, metrics. Okay, again, here it should not be metrics, it is metric. So now here you can see, okay, batch encoding, this some problem in batch encoding, line number 21. Okay. Let's see again. So now here you can see the training has started, and here for my system it is showing 24 minutes. It will be completing in 24 minutes. So before that, let's directly jump into the results, how actually it will show it up to you. You can go for the training, you can wait for 25 minutes, 25-30 minutes and see how the results looks like for you. You can go for the other approaches as well. For the ensemble models, you can combine few models. So that all you guys can do and submit it in the competitions, and submit your submission files also into the by creating a new submission. So before that, let's directly see how actually the results will look like. So I've already done the training. So this is how actually the results will look like. So here the learning rate will show you up, and losses will also be show you up. And here you can see evaluation loss is 1.6, and evaluation accuracy, which I have got for BERT model, that is 40.9, and all other parameters also you can see for the training steps, training loss, and number of epochs, that we had only one. Probably you can go for more epochs if you have a better system and good GPU. So yeah, so here we have the sample submission file. So now let's quickly see. So here the training is still going on. It is going to take probably, now it is showing 1 hour. So let it continue, and let's see how actually we can submit a submission file which you are going to creating at the end of when this thing is going to be completed, when the training is going to be completed. So it will look something like this. It will have the ID attribute and the gender attribute. So let's see quickly how actually we can submit. So here I'm bringing my screen. So here by going into the new submission, very firstly you have to go into the competitions page. Here you have the overview, and here you can see in the top dataset, public leadership, private leadership, and here new submission. Here you can click, you have to click it here in new submission. Afterwards you have to copy your token and put the token here, this space, and after that here you can drop in your submission file, or here you can click and sample submission. Here I'm submitting it and upload submission, and it's submitting, it's processing it. So it will take a short. Yeah, so here we can see the successful submission, and I have only 4 submission left for today. So for seeing my submissions which I have submitted, so I can go to the my submissions. I can directly put in my token and fetch my submissions. So currently it is showing error, but yeah, you can see all the submissions which you have done. So here also, here you can see the submission which you have done. You can download it, and yes. So I hope so. Most of the things, how primary things, how actually you can create your model, how actually you can code the tokenizer, and how you can create a, how actually you can pass the arguments. So I hope so. Almost all the things are clear to you. If there are anything which we can answer, you can ask us. Yeah.
Thank you so much, Prashant. That was a great tutorial. So we do have a few questions we will take now, and you were getting an error in my submissions page because that's your first submission and that's still processing. So if you try again, you won't get the error. But anyways, if you get errors, let us know. There is also a community tab where you can discuss and interact with other competitors, and we will also share the code with you so you can run on your own machine or anywhere you want. So the first question that I want to take is the advantages or disadvantages of using trainer inside a train test loop. So it totally depends on you, what you want to use. If you're using trainer, things are much simpler, but you don't have a lot of flexibility. And if you're going for flexibility, then you can use your own train test loop. So I think both of them are going to give you similar results. By the way, Prashant, are you able to hear me?
Yeah, now I can hear you.
Okay, great. So I think the next question is for Prashant.
Okay.
Do I have to
Do I
do
have
something special to use my laptop GPU to train?
So very firstly, you should have Codian in. So these are the basic things which you should have. And other than that, you should also have, as you would have seen in my screen, that it was showing that TensorRT is not present. So you should also have the TensorRT engine. So that would be one of the thing by which you can fasten up your training process. Yeah, so I hope
Great.
so I have answered your question.
Yeah, definitely. So yeah, it's all the basic stuff. I would just use
Yeah.
Anaconda to make things a little bit simpler, and You always have a mess with NVIDIA CUDA drivers anyways, so good
Yeah.
luck. It's similar to the notion of gated fusion. Certain aspects synopsis speak, certain aspects title influences. Do you want to take it, Prashant?
Yeah. So yeah, Sangeeta, as you said, so it's correct as you said, because some aspects are covered by the for the movies. We can't predict the genre of the movie just by seeing the name of the movie, and some of the movies we can predict very easily. But synopsis gives us a quite a good overview, and combining the titles with the synopsis, this gives us quite uh, means handleability, and by combining both of these things we can predict the genres quite good and with a good accuracy. Yeah.
Hopefully, let's see.
Yeah.
So, yeah, so interesting thing is in this tutorial today, we only use a synopsis.
Yeah.
So using title is left as a homework, or maybe it will improve your model, maybe not. So yeah, let us know. Um, in terms of class, is the dataset balanced? Yeah, the dataset is balanced.
Yes.
More or less, it's balanced, and even the public and private splits are balanced. So um, it should be a good competition in terms of we shouldn't have much shake-up of in private and public leaderboards, but we never know. Um, okay, another question is, can I use generative models in case to experimental prompting based strategy? So, do you want to take it?
Yeah. Yeah, sure. So uh, generative models here, particularly, this is just the classification part, and the approach which we discussed, in which we were simply tokenizing it, and uh, particularly we were encoding all the synopsis. We have not used the generative model here, so I'm not sure we can use the prompting based strategy here or not, but you can definitely try it out and share it with us
Yeah,
if
but
it
just
works
just
for.
I
Yeah.
was I was just thinking about it, and I think it might be an interesting approach. So if you want to,
Yeah.
maybe you can generate lots of synopsis and for different genres and try to train a model. So you will be
Yeah.
enhancing the training data. So maybe it will work. I'm not sure because I haven't tried it, but maybe it will work.
Yeah, probably that can be the case of the creating the synthetic data and trying to train mix it with the trained data which we have given. So probably that can work. Yeah.
Definitely. So test dataset does not have labels. Won't dataset class throw an error? So test dataset do have labels, but they are fake labels. So all of them have been labeled as action. So it won't throw an error. Um, let's take the next question. Which architecture you suggest for a system with lower computational power? So, like in my opinion, the dataset is not very big. So you can also use Colab, and you can use bigger architectures like even dBERTA, Roberta. I don't know if the large versions of those will fit, but today we tried BERT, and that should work quite well for a system with low computational power. And yeah, you can just use Colab if you want to do that. Go with bigger architectures. Do you have anything to add, Prashant?
Yeah. So so if you want to use this particular data set or any data set, and you have a low computational power, so as one thing has been suggested by the Abhishek, you can use the Colab. Other than that, you can um, use sklearn. Sklearn is having quite a good um, trees architectures, naive Bayes models also we have for the classification. You can also try the SVM. So it is one of the good model for the classification of the text. So yeah, these are the few architectures, these are the few models which are available, which you can try it out on the low computational power.
Definitely. So I think you can also try to combine these traditional machine learning approaches with deep learning approaches, and maybe it will perform much better. So I think that's all the questions. Where can I find the code example you just shared? We will share it in the community tab in the competition page, and you can find the link to the competition in the description box. And let's take another one last question. So I think this question is for Jan. Apart from specific genre prediction, what is intuition that's tested in the competition apart from using a text classification problem?
Yeah, I think with like any competition, right? What we try to do, and it's it's a fairly simple example, but at the end, it's also about business problems you want to solve, right? You always have to think about like whatever machine learning problem you're working on. There's the technical aspect, like building a model, making good predictions. But as a data scientist or as a machine learning engineer, at the end, you always have to think about a business problem you want to solve, especially if you work at a company. This is what's all about. Like, how can you make an impact to the business? And I think for this competition as well, and in the competition description, we highlighted a few ideas why this is relevant. To know or to be able to do movie genre prediction. But for me, just to highlight the fact, like whenever you're working on a problem, really think about the business and the business impact. And I think that's something we also want to try to do with this competition and any other competition we're going to do in the future. Even if you go back, like our first competition on Hugging Face was around ship detection. It was an object detection competition, and even there we highlighted the problem that this can solve in the real world. So that would be my answer to your question.
And just to add, like from my side, it's all about having fun. Have fun in the competition. Discuss a lot with other competitors. It's like from my perspective, is bringing the community closer, and you will get a lot to learn. You will learn a lot of new things by approaching the problem on your own, and also from what other people share. So yeah, go have fun, and there's some really cool prizes that you can win in this competition. And if you have any questions, please feel free to reach out to us using the community tab, or to Jan or me or Prashant directly. And this video is going to be available later on, so you can watch it anytime you want. So thank you everyone for joining. Jan, would you like to add some
closing
final words?
remarks? Yes,
Yeah.
yeah, also from my side, thank you so much for your interest in this competition. We really hope, like Abhishek said, you have fun with this competition, you learn something new, you practice your skills, you learn from others, you connect through the community. I think there's a lot of important aspects to this competition, besides just building a model. So best of luck with this competition. Yes, use the community tab in case you have questions. And I also want to say thank you to Prashant. This was a really good walkthrough of the coding part. So thank you so much for doing this. And of course, thank you, Abhishek, for all your support, and also Hugging Face's support, that we're actually able to do those competitions on the platform. Without Abhishek, it wouldn't have been possible to build this on our own. So it was a team effort and a good collaboration. And hopefully we will be able to, provide more competitions in the future. But now for the next 6 weeks, please focus on the movie genre prediction competition and try to build good models and submit your models and your ideas. Thank you so much.
Thank you, Jan, and thank you, Prashant, for
Yeah.
the awesome tutorial. And thank you, everyone, for joining. And we will see each other next time. Bye bye.
Yeah.
Bye, everyone.
Bye bye.